Hello, everyone. So yes, I'm Ricardo. I'm an open source evangelist, and I've been working in open source for around 20 years now. And one of the things I love about working with open source is how open source builders come together to solve problems. And so in this session, I want to show how open source builders came together to solve a problem around data pipelines. So businesses are increasingly trying to understand how to manage their data. And if you think about all the steps that you need in order to get insights and value from data, from the source of the data to moving it around, cleaning it, preparing it, and then putting it into the hands of the people that need it in a secure way, typically organizations have done this in the past in very ad hoc ways, and they built their own systems, typically scripts to do this, and then they would run cron jobs. And that was fine when you were starting off with data, but as you started to grow and started to scale, that became a big problem. And one company that was increasingly struggling with this was Airbnb, a very data-driven organization. And within the data engineering team at Airbnb, they started putting together this project, this open source project called Apache Airflow, which they used in order to effectively create and automate all the steps needed to go from the source data all the way to the end users so they could use the data. And that was around 2015. It incubated as a main Apache project around 2018-19, and it's been growing in popularity ever since. And now there are literally thousands of developers all over the world that maintain it, contribute to it, and build upon it. And so in this session, I'm going to kind of like build upon and show you how all the kind of fundamental kind of core components of Apache Airflow, and then we're going to build our first workflow, and hopefully that you'll then be able to use this and experiment and explore how you can use this in your own use cases. So the first thing really I want to talk about is when you think about all the tasks you have in a data pipeline, we have this unit of work called a task. And effectively, the definition of a workflow is the collection and grouping of all those tasks. And in Apache Airflow, this workflow, or sometimes called a DAG, Directed Acyclic Graph, is represented by Python code. And this is a very basic one. And we use the Python code to find the characteristics of our DAG. And I'm going to walk through actually creating our first one. Now, a task is a piece of code within that Python code which represents a unit of work. And actually what I didn't mention is that our DAG itself at the bottom, each piece of Python code, each DAG has a unique identifier called the DAG ID. And the units of work, the tasks that we want to automate, also have a unique identifier called a task ID. And we'll see how that looks like when we actually do the code. Now, tasks, as these are our units of work that we actually want to build our pipelines with, they use these things called operators, which are an Apache Airflow thing. And there are different kinds of operators, but what these do is you can think of them as templates, and they remove a lot of the undifferentiated heavy lifting and simplification so that it allows you to easily work with lots of different systems. And I'm going to show you in a second what all the different kinds of systems you can work with. But there are kind of operators that allow you to actually work with upstream systems or downstream systems. There are operators called sensors that allow you to wait and sort of detect and then do something. And there are other operators called hooks that allow you to simplify how you connect with upstream and downstream systems. So things like connection strings and passwords, that kind of thing. And over the years, the Apache Airflow community have built integrations into probably most of the data tools that you're using today. Okay, and if what you're using today isn't there, you can easily build your own ones as well. So just to summarize, a workflow in Apache Airflow, a DAG, is a collection of tasks. These tasks are, and it's all Python code. And there is the relationship between these tasks is defined within the actual code, which is the next one here. Okay, so you define using either the greater than or less than, or the method, and that's how you define the relationship between the different tasks. And I think this will become much easier to understand when I go through the actual code demo. Now, before I do that, it's important to understand some of the kind of architectural concepts of Apache Airflow. Because once we've got our code now, we've got a Python file, which is our workflow, and this is a file that might even import other Python libraries we want to use. We deploy it in Apache Airflow in a special folder called the DAGs folder. And you literally just copy your Python file, and if you're using additional Python libraries, your requirements.txt, you put it into this folder, and then Apache Airflow takes care of loading and installing any dependencies, and then makes it available within the Apache Airflow environment. The next thing is, once we've actually got our workflow, okay, how do we know, or how does Apache Airflow know when to run them? And that's the job of the scheduler. So the scheduler will read the code you have, and there's a special parameter that's called scheduled time, which we'll see in the next slide. And this allows Apache Airflow to build a plan when it needs to run the specific tasks within the workflow. And the scheduler will create a plan, and then it will then hand it over to an executor. And the executor's role is to actually run the task. And this is what it looks like from a code perspective. Within the DAG code, which you'll see later, there is a scheduled interval equals. Now, within Apache Airflow, you don't have to schedule everything on a schedule. You can create pipelines that run on demand, and then you specify equals done. Or you can use the cron tab format, which is on the bottom left here. And anyone who's used cron will be familiar with that format, okay? And so you can run it every 2 minutes, every hour, every day. Now, one of the criticisms of Apache Airflow was that the scheduler wasn't very flexible. So recently, with a newer version of Apache Airflow 2.2, they released a thing called timetables, which is the thing on the right. And that allows you to do much more flexible things and define a timetable that might be specific to your business. So you might have some specific events that happen maybe occasionally in your business. You can create now a schedule that maps to that. And one of the important aspects, and one of the things that when you're starting with Apache Airflow that's really difficult to kind of get your head around, is how Apache Airflow actually runs tasks. So you create your DAG file, which has tasks, and you create a schedule. When you deploy that into Apache Airflow, what will happen is if you're running on a schedule, the scheduler will look at what's called the start date, and that's the thing that's in orange. And you can change that. You can define that within your workflow. You can be, for example, today. It could be a date in the past. And the scheduler will start to map and create slots for running all the tasks in your schedule. What this means is that if you, for example, specify that my start date is yesterday, and you submit your task and you run it, most people get confused because their task now has, if you're doing it on an hourly schedule, for example, you now have 24 slots, and your task will run 24 times before it runs today. And so that's something to be aware of. Now, you can turn that behavior by disabling the catch-up equals to false, and then it will ignore all the stuff in the past. But that's something that you have to be aware of, because it is something that the scheduler is managing how many times your task runs. Now, the reason why this is important is it's actually a very powerful feature of Apache Airflow that allows you to do this thing called backfill, which is if you're having data pipelines, and let's say either something in your data pipeline upstream breaks, or maybe you've got a query that you want to change, you can change that query within your workflow, resubmit it, and then Apache Airflow will go all the way back to your start date and rerun across all your data. So when your workflows are running, one of the things that happens is there's lots of state information, lots of status of the current tasks, the workflow that are being written or created rather, and that needs to be written somewhere. And this is where the metadata database comes in. So any of the information that's generated as part of running your workflows, as well as state between tasks, because every task within Apache Airflow is stateless. So if I run a task, say for example I want to copy a file, the next task won't know about that because it's stateless. And so you can actually push and pull data from the metadatabase in order to manage the state. And then the final part is actually the web server, which is actually the UI, the UI, and how you interact with Apache Airflow. And actually, it's probably one of the reasons why Apache Airflow was originally very popular, because at the time there weren't very many tools out there that provided a nice GUI to organize their workflows. So that's enough of the slides. I want to try and get into code as quickly as possible. Thank you. And this is what we're going to build. We're going to build a very simple data pipeline, okay, that takes some data from a Movie Lens database that we're going to combine 3 different sets of data. We're going to merge it into a single data set, and then we're going to do some cleaning. And in this instance, I'm going to remove the letter E from all the movies, and I'm only going to select all the movies greater than rating 4. And then we're going to put them in our data warehouse, okay? Most of this is running locally on my laptop. The only bits that I'm going to be interacting with is obviously when I'm uploading to S3, Athena, and Redshift. So I'm hoping that the Wi-Fi is going to hold up for me. So I'm going to come out of the here now. I haven't, unfortunately. I normally have a little cuddly toy that I've somehow started using, and it's given me luck, and I left it at home, so I'm hoping it's okay. So. Also, all the code and everything I'm going to be showing you, I've got available on a GitHub repository, so you can do this yourself. And I've also created a blog about it, so it actually walks you through every single little step. So actually, let's go here first. So there's a project, an open source project that we created about 2 years ago called Moi Local Runner, and it's effectively a Dockerized version of Apache Airflow. And I've run this in the background. I've already actually got this running to save some time. And we can see we've got the DAGs folder here. This is our special folder where we copy our DAGs once we've created them, and it will kick in. So I'm going to do the first DAG here, and I'm going to walk you through what a typical workflow looks like in Apache Airflow. So the first thing is we import the DAG object from Airflow. And this actually creates our workflow object, which Apache Airflow will actually understand. We can then create and import any additional Python libraries we need. So in this instance, I'm doing some time. And then we have our first operator, our first Apache Airflow operator. Here I'm using a bash operator, because all I'm going to do is interact with bash, so run some bash commands. We then have this JSON object called default args, which you have and you submit to your DAG object. And this is where you define common configuration parameters for your workflow. So things like here, my email address, but also some additional things such as, failure callbacks, success callbacks, that kind of thing. I've just commented them out here, and that's like beyond the scope of this basic session. We then have this DAG ID, which is the unique identifier for the workflow. So here I've got PyCon demo schedule DAG. And then we've actually got an instantiation of our DAG object. So here we've got, we pass in the DAG ID, so the unique name of our DAG. We pass in those default arguments we've created. We give it a description, and then we specify a schedule. So here, this is going to run every 2 minutes. And then the start date here is 2 days ago. So again, the scheduler is now going to go back, because I've not set up catch-up equals to false. It's going to go back and run those. And then you can also specify some tags. So when it actually comes to what the operator looks like, we can see here that we define an operator as a chunk of code in Python, and each operator has its own parameters, okay? And rather than you have to know how, for example, to interact with a specific database or a data warehouse, the operators are documented on the Apache Airflow document, and all you need to know is the parameters, and you submit the parameters in the workflow. And this is how it makes the life of data engineers easy. So in this instance, the only thing I need to pass into this operator is a bash command. And then, so I've got 2 tasks here, 2 tasks using the bash operator, and then I define the relationship between them. So I want say hello and say goodbye. So I want one task to follow the second task. And then all I need to do is copy this into this folder. And I'm then going to switch to the UI of Apache. So this is the Apache Airflow UI. It doesn't look very interesting when you first start it and you've not got any workflows. We have some menu options at the top. The one we're going to look at mostly is admin, but it gets more interesting as we actually start to see workflow. So we've now got our first workflow. By default, when a workflow is added, it's disabled, so it's called paused. We can enable it by unpausing it, and we now actually have our workflow running. I can click on it, and we can actually now see the status of our workflow. What does our workflow look like? So we've got 2 tasks. You can see there's a color around each box, and each of these colors corresponds to a specific information that we can understand whether our workflow is healthy or whether our workflow is stuck somewhere. We can actually click into each specific task, and then we can actually look at the metadata, and this metadata is stored in the metadatabase. And we can also look at the output of this. So here, this was a very simple example of just echoing hello and goodbye. We can see that we've got the information output here. And because this is running on a schedule, what we'll see, if I go on here, you'll, well, I'll come back to this in a second because you'll start to see every 2 minutes we'll have another row of tasks being completed. Now, one of the nice things about Apache Airflow is as you build your workflows and they run, you can start to try and optimize your tasks by looking at some of the reports it generates, for example, the task duration, task tries, landing times. Now, it's not going to show anything useful here because we've only got 1 task running, but this is how you can use the UI to help you optimize your data pipelines. Let's look at something a bit more interesting now. Let's look at that example. So I'm going to go back to here. So if we look at the example I was going to say, these are the if I'm a data engineer, these might be the typical steps that I might need to do to build a data pipeline. Okay, so I want to actually find, I can't really see it on my screen, so I want to actually copy and find the data. I want to store it somewhere on S3 in this instance. I then want to merge it. I then want to clean it, and then I want to store it in my data warehouse. So these are the steps. And so I've broken down each of these steps and the operators that I'm going to use. So let's have a look if I can make this bigger. So the first task is to actually copy the data, right? And I'm using 2 operators, Python operator that allows me to define a Python function and then call it within an operator, and then an S3 sensor, which allows me to check to make sure a file is in an S3 bucket, and then once it is, then complete and go to the next task. So that's what I'll use for the first thing. And I'm going to show you the code as well. I just want to walk through, first of all, to make it easier to break down. Once I've got that, okay, I want to ingest that data into my data lake. So I'm going to use the Athena operator. And this makes it super easy for me to actually then take some files and then define my Athena SQL and then use that within the task so that then Apache Airflow can manage that for me. Once I've done that, I'm going to then use the same script, same SQL, to actually take 3 different files and merge them together using the same operator, the Athena operator. And then I'm actually going to consolidate, again using the Athena operator. And then I'm going to do some very crude cleaning. So this is where I'm going to strip all the letter E's from all the movies. And I'm going to use the Python operator to do that. And then finally, I want to actually upload this into my data warehouse. And so to make this really, really simple and not have to know about how to interact with Redshift, I can use the S3 to Redshift operator. And this simplifies how to do that. So now let's just go into the code. So I'm not sure. Is it okay? Can you see it at the back okay? Is it just about... I can try and make it a bit bigger, but actually I can't do that because I can't see it. So you can see here that, again, it's the Python file. You can see I'm importing some additional operators and some additional Python files, although I'm not using all of them. I have a simplified default args. And then in this instance, rather than hard code the name of the DAG, I've actually just using this piece of code to make it the same as the Python file name, bless you. Now, another function within Apache Airflow is you can use the UI in here to define variables. Okay, and I've already done this. I've imported them using a JSON file, which is here. So you can define variables, you can import them into the UI, and then you can refer to them in your code by using another, where is it? Here. Another class within Airflow that allows you to effectively import variables from which are stored in the metadata database. So here, rather than having to hard code them in the actual workflow, I can just make a templated workflow and then just store that information and reuse this over and over again with different data. Then I actually create some SQL queries here, which again I could store externally, but for the demo I'm just doing there. And then I've got the various Python functions. So here, this is the cleanup Python function, and all you can see here is basically it's just removing the letter E. So if I go to the bottom now, you can see the different tasks and how I call the different operators. You can see, for example, here I don't have to know about Athena operator. All I've got to do is pass in the query, the output location of the query, and then the Athena database, and then it takes care of everything else for me. And then I'm going to the end, and then I define the relationship. So this is the relationship of the different tasks within the workflow. Now I'm going to copy this because I'm running out of time. I'm not going to be late, and this is going to work. So I'm going to, hopefully in a few seconds, this should come up. Come on, yes. So we now have our more complicated pipeline. So you can see here all the different steps. We copy the file in the first two steps. We then extract the three different files into using Athena. We join them into a single data file. We clean it up, and then we transfer it onto S3. And if I enable this, this is where I'm hoping that the demo gods are going to be kind to me. This doesn't normally take very long. So we can see the status of these tasks. You can see that because we've defined the relationship of the tasks, is this task here then splits off into these three different tasks. You can have one task that goes to many tasks. You can have branching, but it's always one direction. It's not circular, right? That's the whole point of directed acyclic graphs. Now, whilst we're waiting for this to finish, I'm going to go back to the other task we had, and we should be able to see now it's been running a few times. So now, hopefully, this is finished. It's still running. I've got 2 minutes for this to finish, and it's going to be tight, but it will run. It will finish. It will finish. But what we'll see, okay, is we'll go into the cloud and we'll go into our Redshift data warehouse, and we'll run a query. Oh, look, it's still not doing it. Come on, go faster. Go faster. So yeah, so while I'm waiting for this, okay, let's just finish the slide so we can come back and see this. So we will come back to this. I want to cover very quickly, though, the Apache Airflow Summit was last week, and I've shown you kind of the basics of Apache Airflow, but Apache Airflow as a product is continuing to evolve and continue to innovate. And some of the kind of main ones, really, that we're seeing in 2.2 and 2.3 around scheduler optimizations, better options for running asynchronous workflows, actually creating workflows. When I showed you that Python code, it may not look like a typical Python file. And so work is going on to make Airflow's DAGs look more like standard Python code. And so there's a lot of new SDKs around that. And then there's lots of improvements to the UI as well. Oh, it's definitely going to work now. Come on. Oh, no, it didn't work. Look at that. So we had a failure, which is actually quite good, I guess. So we can see why it failed here. And why did it fail? Oh, that's why Redshift isn't okay. The reason why it didn't work is because I didn't create a connection to Redshift. I don't have time to do that, I don't think, do I? I can try. I can try. Let's do this quickly, because all the information is already here. So let's do the password, and then I can show you a very powerful feature of Airflow, which when a task fails, you don't necessarily want to run the whole workflow again. Okay, so here, all I have to do is click on the workflow, clear this state, and it's going to retry that one task. And hopefully now, because hello, it worked. Yes. And we can see the output of that, but we can also, more importantly, if we go into actually the workflow, we run a query. Come on. I know what time. I know. I'm not looking. Right. Let's run. Come on, run. Here we can see we've run a query, and if we look, we can see there's no letter E's in any of these. So that's our workflow. And obviously, in your own workflows, you do something more important. So that's actually the end of the talk. Before I finish, Apache Airflow, if you're looking for an open source project to contribute to, Apache Airflow is a fantastic project, very welcoming, great documentation. Here are the links to the demo code, as well as Apache org, and you can actually get a copy of the slides if you click on that QR code and just complete a very short survey, and it will send you a PDF link to that. Feel free to connect with me. I'm around all day today, so if you've got questions on Apache Airflow, then come up to me. With that, I'm done.
Yes, now it's time for questions. Now we have 3 minutes to do questions that we're already done. We're performed at least some of them that I'm gonna read.
Yep.
And then anyway, as he said, he's gonna be around, so please.
Yeah, come find me.
Yeah. And also on Discord, you can find him on Discord. You're on Discord, right?
I'm on Twitter, on LinkedIn. I'm on the Apache Airflow Slack communities as well. So
yeah, let's go through the questions. So the first question is, has every task its own process, like Python.exe? Well, it's not exactly Windows, but yeah, has its own process. Yeah, I'm gonna, like process, parallelism.
Parallelism.
Yeah, I'm not the one doing the question.
I'm not sure I understand the question.
So.
So the question is, you have like all the tasks, and do they run in like a separate Python executable, or in one instance, and do they parallelize?
So the scheduler parallelizes, so you can define and can tune that based on your setup, but you can run hundreds of these in parallel. Yes.
So on 100 cores.
So well, it depends. There are some limits, and obviously the Apache community is trying to optimize that. But some of the things that you have to bear in mind, okay, is first of all that tasks are stateless. So don't assume that one task will run on the same node as another worker. But they will be parallelized, and the parallelization is configured and tuned by the scheduler and the executor. So depending on the executor you use, so for example, if you're using the Kubernetes one, it might fire off like hundreds of pods to run your tasks. Yeah, they're not serial. They will run in parallel.
Okay.
On my one, because I'm running locally, it doesn't.
Anyway, it works with Celery too, and so
it does.
Which is
yes,
natively
absolutely.
Multi-process. So the next question is how to manage input-output between tasks, even large ones like full data sets.
Yeah, that's a great question.
Great question for Airflow.
Yeah, so for small data sets, there are a number of different strategies. Typically, you use the state information stored in the metadatabase, but that has its own overhead. So if you just, for example, want to get a query ID, like in the example when you look at my code, I do that. I pull information from the metadatabase because I need the query ID of the previous task in order to run the current tasks. If you've got, for example, if you're writing a big dump of data, then typically what we find people doing is using the S3, the sensor operators. And effectively what you'll do is you'll have an operator that will, or you'll have a task that writes information somewhere, and the subsequent task will pick it up. So it's like a drop, a pop and push operation. That's how many people do that. So, but there, I think in Apache Airflow, there's no one right way of doing it. It depends on your use case, but there's lots of different ways you can achieve that in Apache Airflow.
So last question is, any other languages supported?
No, it's Python.
But it's Bash. I mean, you can run other languages.
So exactly.
Bash.
So the operators. So what I do another talk on Airflow where kind of one of the best practices of using Apache Airflow is to containerize your ETL. And if you do that, effectively you use your existing container development lifecycle, and then you can use whatever language you want. Because all you're doing is you're passing in, you're executing a container and passing in parameters. So the demo I do actually is still using Python, but you could use Spark, you could use Go, you could use anything you want, because you're just kicking off the task within Airflow. One of the mistakes that we do see people do is they try and do all their processing within Apache Airflow. Apache Airflow is an orchestrator, not a processor. So use the operators to do the heavy lifting in other things, like Apache Spark, you know, or you know, in a container type system.
Yeah, also because the problem is that all the requirements and the dependencies are going to clash.
Yes,
together.
exactly.
So yeah, thanks everybody. Thanks also to Ricardo.
Thank you everyone.
And see you soon.